In this video, we will talk about operations in Python. First basic operation we all know in addition. It's declared variables first, and for example v1 equal to 11, v2 equal to 10, v3 equal to v1 plus v2, and then we print the value of v3. We run this file. And you can see the result is 21. This addition is affected and stored in v3. v3 is a variable which is stored in our random access memory, in our main memory. I mean there is affectation, but we can do this directly here. v2 plus v1. This summation is affected but is not stored in any variable. This is the main difference. Now we have seen the addition in v1. Now let's see how we can use subtraction. Before equal to v1 minus v1 minus v2, and then we print it. So our result is 1, and this is it. It's very easy. Now let's see how we can use the multiplication. v5 equal to v1. We use the star, v2. It's almost the same for all programming languages. I mean, these operations are usually the same, so you can see the result is true here. The same goes for division. But this time the v6 will be a float rather than integer, and we will see this now. Print it. You can see the result is 1.1. The use of these operations is easy in Python, and there are extra operations that we will see later when we talk about modules. For example, the mathematical operations like cosine, sine, and exponential and logarithm, and so on. These are basic arithmetic operations that we'll usually use. We will talk about other operations in later videos. Also, we can use the logical operations like AND and NAND, NOT. For example, if we declare in here boolean 1 equal to true, b2 equal to false, b3 equals to b1 and b2, which is straightforward. It's easy, directly the right end. We'll see what would be the result. b3 here. False. It is written false because true and false is false. We can use the OR. And the result will be true. This is true, I mean. Now this is a single bit. We can represent the any number in binary in Python by easily using the b function. For example, we have v7 equal to 15, and before equals to binary version of v7. That's right. Let's print the value of before and see what happens. You can see this 0b means are in binary in the x, for example, and let's see what happens exactly. It will print 0xf, the hexadecimal of version of this variable, and you can use the same for octave. This is our result. Now let's back to binary. For example, let's declare this and v8 equals to, let's declare a new variable here, equal to 10. And 10 will be in binary like this, 1010, and this is 1111. And v9 equals to v7 and v8. Let's print the binary version of v9 and see what would be the result. It takes this value because 1 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, and finally 1 and 1 is 1. So when we use the OR, I think you know what the result would be. These zeros, it turns into ones because our variable here is our bits here are all ones. Let's check the result. That's it. Now let's see how to use the Xor function. We have our variables that we are working here. Let's store the result in v10 equals to v7. We don't write Xor like this. We just use this operator here, v8. Then we print the binary version of this result. You can see the result here because 1 XOR 0 is 1 because they are different. 1 and 1. 1 XOR 1 equals 0 here. 1 XOR 0 is 1. 1 XOR 1 is 0. The zeros from the left side, they are not shown. So that's it for the XOR function. Now let's see how to use the logical shifting. For example, if we want to shift this variable here to the left or right, use v10 example equals to v8 shifted to the left by 2, version of v10. This is our original variable, and then we shifted this back to the left by 2 zeros. That's it. Let's try to shift this this variable to the right by 2. So now let's see how much will be the result. It takes only these two values, and that's it for this video. I've seen how to use operations, logical operations, and arithmetical operations. As I said, we will see other operations in later videos. I hope you enjoyed this lesson today, and see you to the next video. Ciao.